Okay, this is the study guide for Unit 7, Test 1. Make sure you fill this in as completely as possible because you can use it on the test, and most of the problems on the test are going to look a lot like this. So if you can understand what I'm doing here, you'll be okay on the test. First problem is a dilation. It wants me to dilate the rectangle you can see here, ABCD, by a scale factor of 2. What that means is that I'm going to take each one of these points. I'll start with A. I'm going to find their coordinates. So A is at 2, 3. And I'm going to multiply the x and y values by the scale factor, this 2 right here. So A prime, my new A, is just going to be at whatever the x times 2 is and the y times 2 is. So the new A, or A prime, is going to be at 4, 6. Do the same thing with B. B starts out at -4, 3. If I multiply both of those by 2, B prime is going to be at -8, 6. Do the same thing with C. C is at -4, -2. So C prime is going to be at -8, -4. And D. D is at 2, -2. If I multiply both of those by 2, D prime ends up at 4, -4. And then I can sort of sketch in my dilated rectangle from there. Next one, I have a triangle. Scale factor this time is 2/3, and because 2/3 is smaller than 1, I'm expecting that the triangle is going to get smaller. Start with A. A starts out at 3, 6. And so I'm going to multiply both of these values by 2/3, just like I was doing above. The only thing that's different is now we're multiplying by a fraction. Here's how I multiply 3 times 2/3. When I want to multiply a whole number like 3 by a fraction, all I do is multiply the whole number by the numerator, by the top part of the fraction. So 3 times 2/3 is the same thing as 3 times 2/3. I leave the denominator alone. So 3 times 2 is 6. So now I have 6/3. 6 divided by 3 is just 2. So for A prime, my x value is 2. Now I'm going to do the same thing with 6, right? The y value of A. So A prime is going to be at 2, 4, which is right here. Now B starts out at -3, -3. So I would multiply both of those -3's by 2/3. Luckily, I only have to do it once because -3 is the same thing as -3. So I would say, I'm just going to come over here for space. -3 times 2/3. I just multiply the -3 by the 2. That's still over 3. I don't change the denominator. -3 times 2 is -6. So I have -6/3, which is the same thing as -2. And I could go through and I could do that again for this the y value, but I don't have to. Right? I know it's -2. So B prime is at -2, -2. And then C is way out at 9, -3. Multiply both of those by 2/3. 9 times 2/3 is going to be 18/3, which is 6. So C prime is going to be at 6. I already know -3 times 2/3 is -2. So C prime is at 6, -2. And so I'm going to draw in my triangle here. I'm just going to do a rough sketch. And there you go. All right, turn to the next page. What these problems are asking, these first 8 problems, is if this number right here, 3, is my scale factor, is this going to result in enlargement or reduction? So all I'm doing here, if you want to make a little cheat sheet, is if k is greater than 1, you're going to have an enlargement. If k is less than 1, you're going to have a reduction. Okay, so is 3 greater than 1? Yes. So I would have an enlargement. Is 2.5 greater than 1? Yes. So again, I'm going to have an enlargement. Is 0.9 greater than 1? No, it's less than 1, so I would have a reduction. Is 1.01 more than 1? Yes. So I have another enlargement. Is 3/4 greater than 1? No. So I'd have a reduction. 5/2. If you can't look at a fraction and tell right away whether it's an enlargement or a reduction, just get your calculator and divide the top number by the bottom number. So if I got a calculator out and I did 5 divided by 2, it would give me 2.5. And 2.5 is greater than 1. So I have an enlargement there. Same thing here, 8/9. If I can't tell right away whether 8/9 is greater than 1 or not, do it on your calculator. 8 divided by 9 gives me 0.888, which is less than 1. So it's going to be another reduction. 9/8. Well, if I have more on top than on the bottom, it's going to end up giving me a number greater than 1, so that's an enlargement. All right, next problem. I have triangle ABC here, and then I have 4 smaller triangles underneath of it, and my job is to figure out which, if any of those 4, are similar to triangle ABC. And so what I'm looking at here, since the only information I have concerns the sides of the triangles, is I have to see if corresponding sides have the same ratio, right? So I'm going to compare ABC to each of these 4. I want to see if the corresponding sides have the same ratio for all three pairs. So I'm going to start up here. The longest side on AC is 9. So I'm always going to start there. And I'm going to start with this small triangle in the upper left. The side that corresponds with AC down here is going to be this one that's 4.5. 9 divided by 4.5 is 2. So I'm going to now move back up to the big triangle. Side BC is 8. The side down here that corresponds with BC is this one here that's 4. 8 divided by 4 is 2. And then the last side on ABC is AB here, which is 5. The side that corresponds with it down here is 2.5. 5 divided by 2.5 is 2. I have the same ratio for all 3 pairs of corresponding sides when I look at those 2 triangles. That means they are similar, so I can circle that one. Do this one in a different color. Now I'm going to compare ABC to this triangle over here on the top right. Okay, so I'm going to start again with side AC because it's the longest one on triangle ABC. The side that corresponds with it down here is this bottom one, which is 11. 9 divided by 11 is 0.818. Next, BC, which is 8, corresponds with this side here, that's 10. 8 divided by 10 is going to be just 0.8. And so now I'm going to compare the ratio I got when I compared AC to its corresponding side to the ratio I got when I compared BC to its corresponding side. They are not the same. That means this one is not similar to ABC, right? If I get even one pair of ratios that are not the same, not just close, but not exactly the same, those 2 triangles are not similar. Next one, I'm going to do the one on the bottom left. So again, I'm going to start with AC, which is 9. The side that corresponds with it down here is 13.5. 9 divided by 13.5. 0.6, repeating. Side BC is 8. The side that corresponds with it is 12. 8 divided by 12, 0.6 repeating. Last one, BA or AB is 5. The side that corresponds with it down here is 7.5. 5 divided by 7.5 is going to be 0.6 repeating, so this one is similar. And then I just have one left to compare. Start again with AC, which is 9. The side that corresponds with it here is 7. So I'm going to do 9 divided by 7 to get that ratio, which is 1.28, and I'll stop there for now. Now I'm going to do side BC, which is 8, over its corresponding side, which is 7. So I'm going to do 8 divided by 7 on the calculator, equals 1.14. These two right here are not the same, so now I can stop there because I know that that triangle is not going to be similar to triangle ABC. All right, if you turn the page again, you'll see this question. It says, find Y if MNO is similar to PQR. So we're not trying to figure out if these two are similar. It's telling us that right here. What we're supposed to do is figure out what this Y right here is equal to. Okay, so if I know these two triangles are similar, it means I'm going to eventually set up an equation where I have two ratios that have to be the same. Okay, so I'm looking at triangle MNO, and what's the longest side here? Well, I know it's not NO. If I compare MN to MO, I can see that if I sort of like rotated this one down, it would stop right here. And so what that means is MO is my longest side on the big triangle. Okay, so I'm going to start setting up my ratio. MO corresponds with which side on PQR? Well, the longest side I can see between these two is definitely RP, right? It's 5, whereas QP is 4. Okay, so that ratio between the two longest sides of these triangles has to be the same as the ratio between any other pair of corresponding sides in these two triangles. So what are the other two sides that I have information about? Well, back over here, I have side MN, and it is like the second longest side in the big triangle. So I'm going to look for the second longest side over here, which is QP. Okay, so what I'm doing here is I'm setting up a ratio based on the knowledge that these two triangles are similar, and that because of that, any pair of corresponding sides has to have the same ratio as every other pair of corresponding sides. So now I'm going to plug what I know into this equation I've created. I know MO is 10. I know RP is 5. I know MN is 2Y plus 3. And I know QP is 4. We've gone over this a couple times, but if you forgot, that's all right. What I do when I have fractions on both sides of an equation is cross multiply. So I'm going to multiply that 4 by 10. So I'm going to do that on one side. I'm going to have a 4 times 10 equal to this 5 multiplied by 2y plus 3. Four times 10 is 40. I have to distribute the 5 over here. 5 times 2y would give me 10y. 5 times 3 would give me 15. And now I just have like a, I guess, a two-step equation to solve. I'm going to subtract 15 from both sides. It's going to leave 25 being equal to 10y. Then I'm going to divide both sides by 10. Y is going to be equal to 2.5. Next problem. Now it's back to asking me whether these two triangles are similar or not. I don't know anything about how long any sides are here. The only information it's given me right now are angles. Okay, I have 3 different angles in 2 different triangles. Well, since I know 2 of the 3 angles in triangle DEF, I can figure out what this third one is, right? I can figure out what this one down here, angle D, is, because I know that all 3 of the angles are going to add up to 180. And I know there's already an 86, there's already a 40, and whatever's left over is going to be for my angle X down here. So 180 equals 86 plus 40, which is 126. And I would just subtract 126 from both sides. So 54 degrees is what I'm going to put right here. Okay, so I know all 3 angles inside of that triangle. What can I do with FGH? Well, one thing I know is that vertical angles are congruent. And so if this angle right here is 40, this one over here has to also be 40. Now I'm in the situation with the triangle on the right that I was in with the triangle on the left. I know 2 out of the 3 angles. I just need to figure out what angle H is. And I'm going to do it the same way. I know 180 is equal to this angle here, 53, plus this angle here, 40, plus this one that I don't know yet, which I'll just call X again. So 180 equals 93 plus X. And then I'm just going to subtract 93 from both sides. So X, this X over here, I should have called it a different variable probably, but this missing angle over on the right is 87 degrees. So now I'm just going to compare the 2 triangles. The angles that I have inside of both triangles, are they exactly the same? If they are, I have similar triangles. If they're not, I do not have similar triangles. Well, I have a 40 and a 40, so I'm good so far. Then I have an 86. Do I have an 86 over here? I do not. I have a 53 and an 87. So the triangles are not similar because I do not have the same angles in both triangles. Next page. Before I do this one, I want to review something really quick, and it's from last semester. I'll try to be brief with it. If I have 2 parallel lines, let's just say these are parallel lines, and they are cut by a transversal. What do I know about the angles between those 2 lines? Well, I know that alternate interior angles, like those 2, are going to be congruent, whether it's those 2 or these 2. Those 2 angles, if both angles are between the parallel lines, but on opposite sides of the transversal, they're going to be congruent. And that's going to be important to solving this problem here, and you'll see why in a second. Okay, so I have these 2 parallel lines right here, and I know that because of the arrows. So ED is going to be parallel to HG. And then if you look at the 2 lines that make the triangles, they're sort of like transversals. So this line right here is basically a transversal, as is this one right here. Basically 2 transversals cutting these 2 parallel lines. Why do I care about that? Well, because it helps me know what the angles that are missing right now, what they actually are. So this angle right here is 82 degrees. What other angle is the alternate to 82? In other words, what angle is between the 2 parallel lines, but on the opposite side of the transversal that makes the 82 degree angle? Well, it would be this one right here. So since angle H is the alternate interior angle to angle E, this one is also going to be 82 degrees. Okay, and then I can do the same thing. Well, not the same thing, but another thing I know is that if this angle right here is 42, this angle right here is going to be 42 because those 2 are vertical angles. So now I know 2 angles inside of both triangles, and I can figure out the third one. Right? I can figure out what this one is, and I could figure out what this one is. Well, I could go through and do the math. I could say 180 equals 82 plus 42 plus X. I could do that for both triangles, or I could see that these 2 triangles are going to have to be similar. Because if I do 180 equals 82 plus 42 plus X for this triangle on the left, DEF, it's going to look exactly the same when I do it over here on the right. The same equation is what I would use to solve this one over here because I have the same 2 angles. So my third angle, X, regardless of what it is, again, we could go through and we could figure it out, but this is just a kind of a shortcut. If I know that 2 of the 3 angles inside of 2 triangles are the same, then I know that whatever this one is, it's definitely going to be equal to that one right there. So because these 2 triangles have the same 3 angles, yes, the 2 triangles are similar. And I'm just now realizing that's not even what the problem was asking for. What would angle D have to be in the image below? Well, okay, so we did a little excursion. Yes, the 2 triangles are similar. What would angle D have to be? Well, I've already set up the equation for it. So I might as well go through and solve it. 82 and 42 is 124. Subtract 124 from both sides. 180 minus 24 is 56. So this angle right here would have to be 56 degrees. This angle right here would have to be 56 degrees. So we not only know that those two triangles are similar, but we also know now that the missing angles are 56 degrees. Are these two triangles similar? When I want to try and prove two triangles similar, I have three options. I can figure out if they have all three angles the same, if they have all three sides the same, or if they have two sides that are proportional, separated by two angles that are congruent. Let's see what we have here. Is there any way for me to figure out these two missing angles in both triangles? Well, no. Right? So there's no way I'm going to be able to get all three angles for both triangles to compare. So angle, angle, angle is out. What about all three sides? If I want to prove these two are similar, I may have misspoken before. I don't need all three sides to be the same. I need all three pairs of corresponding sides to have the same proportion. But to do that, I would need to know all three sides, and as it stands right now, I don't know this side, and I don't know this side over here. So side, side, side's not going to work either. My only option then is side, angle, side. And if I look at the two triangles, I can see that I do have a side, and then an angle, and then another side on this triangle, and even on the smaller one, I have a side, angle, side. That said, just because I have that information doesn't mean I automatically have a side, angle, side similarity here. I'm going to have to go through and check the ratios between the two pairs of corresponding sides that I have, but that won't take very long. The longest side on the triangle on the left is 21. The longest side on the triangle on the right is 14. And so for these two triangles to be similar, the ratio between the two longest sides would have to be the same as the ratio between the two, I guess, medium sides. Okay, so on the triangle on the right, the medium side is 15. Triangle on the left, the medium side is 10. Does 21 over 14 equal 15 over 10? Right? If that's a yes, these two triangles are similar. If it's a no, they're not similar. So 21 divided by 14, 1.5. 15 divided by 10 is also 1.5. So it checks out. And so that means that these two triangles are similar. And if you get this question on a test, you might have to specify something like by SAS similarity. Next problem you come to in the packet looks like this, and the one below it. Don't worry about doing these two for today. I put these in by accident, forgetting that I was breaking up the chapter into two parts. The questions like these two are going to show up on the Unit 7 Test 2 that you'll take next week, so don't worry about it for today. We're just going to skip down another page to the one that looks like this, because there is a problem like this on the test that you take this week. So I have two five-sided shapes, and I don't have the points marked, but we can say that JKLMN is this one on the left. I'm just going to draw those points in, J, K, L, M. And the points aren't really going to matter for this one. And then on the right, I'm going to have O, P, Q, R, S. Okay, I'm told that they're similar, so I'm not trying to decide or figure out whether they're similar or not. I'm going to find something else out. It wants to know the scale factor. In other words, what did I have to multiply all the sides on OPQRS to get JKLMN? And then it wants me to figure out the perimeter of OPQRS. In other words, how long is it once all the way around the smaller five-sided shape? So to figure out the scale factor, what I have to do is find a pair of corresponding sides. Okay, so that's the first thing I have to do. Well, OP looks like it corresponds with JK right here. And so if OP is 2 and JK is 4, what do I have to multiply by 2 to get 4? That's how I can set up an equation for it. In other words, what I'm saying with this equation is this 2 right here times some other number gives me what that side length becomes when I dilate it. So 2 times something I'm going to call x equals 4. Most of you probably did that in your heads already. X in this case would be 2. So the scale factor here is 2. That's part of my answer, but that's not all of my answer. What other information do I know? Well, these slash marks through the sides indicate which sides are congruent. And so one thing I know right away is that if OP is 2, PQ is also going to be 2, because both of those sides have 1 slash mark through them. All right, well, if I know the scale factor is 2, it means that whatever this side is, OS is, it had to be multiplied by 2 to get 7. So 2 times whatever OS is gives me 7. So if I just divide this side by 2 and this side by 2, it's going to tell me what OS is. So OS is 7 divided by 2, which is 3.5. So this side right here would be 3.5. SR down here, SR. Again, the side that corresponds with SR is NM, which I'm told is 6. So SR, just like before, if I multiply it by the scale factor, this one right here, by the scale factor of 2, I would get NM, which is 6. So 2 times SR gives me 6. Divide both of those by 2. SR then would be 6 divided by 2, which is 3. So this side is 3. And now I just have to figure out QR. QR right here corresponds with LM, which is 8. So 2 times whatever QR is gives me 8. Divide both sides by 2. QR is just 8 divided by 2, which is 4. So this side is 4. So now I have all 5 sides of OPQRS. I just need to add them together to get the perimeter. Okay, so I have a 2, a 2, a 4, a 3, and a 3.5. You can do that in your head, you can write it out, or you can do it on a calculator. I'll just do it the easy way. 2 plus 2 plus 3 plus 3.5 plus 4 is 14.5. So the perimeter is 14.5. And then this problem is another one that's going to be on the Unit 7 test too, so we're not going to worry about that today. That's the end of the study guide. So pause the video, go back, fill in whatever notes you need to fill in, ask me any questions you have, and then as soon as you're done with all that, let me know so I can give you the copy of the test to start.